So this afternoon session of day one considered the complex systems of life and evolution and how today's scientific discoveries and inventions can bring us to exceed the realm of what nature and biology offer. I'd like to again thank our speakers for their stimulating presentations, which I'm sure have inspired many questions. As we don't have too much time, I recommend that you start thinking about your questions now. We've already had some come from our online audience, so if you don't mind, I'll start with one of these. Professor Medal, what are the biggest challenges when applying the mechanism of the click reaction on different reactants, and what parameters do you alter to counter these issues?
I think that depends on what you're doing, because, of course, you need to have your reagents available to each other if they have to react. So if you install alkyne and azide on two different moieties and they never reach each other because they're never in contact, then you will not get the reaction. Another thing is, of course, that you have to keep the reactivity going with this copper-1 catalyst, and therefore you need protective catalyst ligand in order to get that to work over the entire time of the reaction. But I don't see any chemistry related, other than the oxidation of the copper. I don't see any chemistry related problems with the reaction.
Thank you. Would you like to ask your question?
Yeah. So thank you all for some very inspiring talks. I had a question for Professor Arnold. So as a public servant of sorts, what can we as future scientists, hopefully, do to address public skepticism towards scientific innovation, for instance, in the case of mRNA vaccines?
We talked about that a lot. And just 2 days ago at the White House was a science and public engagement event where I wasn't there, obviously, but people on my council laid out plans for doing a far better job of communicating uncertainty, how we change our minds. People, the way that we communicate to people is often, this is the way it is. And in rapidly changing environments, like a pandemic, where we didn't know what it was, we did not convey the importance of being able to change one's mind and the uncertainty involved in any of the things that we were saying. So we need to learn much better how to communicate with people.
Thank you.
I have a thought of how a way of solving the antibiotic problem that I want to share. The problem now is that the bacteria that we try to kill creates a resistance, for example, towards penicillin. But my idea is that we use plasmids that bacteria share with each other to share the genetic, their characteristics to one another, so information. And my idea is that you create a plasmid that tells the bacteria to destroy itself. So you could fill surface with it. And my question is it possible to create a bacteria that produces these plasmids without killing the bacteria itself?
You want it to produce something that'll kill bacteria without killing itself in the process. Yeah. Oh, that's a good one.
Yeah.
That's a good one. I don't have an immediate idea on that, but I think that's the problem you need to solve.
Yeah.
You have a great future in front of you.
Yeah.
I think there is one way of already making things better.
Yeah.
To stop penicillin for a number of years so that the bacteria forget that there's penicillin around and introduce it again.
That's right.
You don't have to do much. Just
shouldn't-
stop some things.
Right, we shouldn't be using so many
Yeah, exactly,
antibiotics.
exactly.
And that's where the resistance, and that's often the solution, right?
Yeah,
Is
yeah.
stop misbehaving.
Exactly. That's good. That's a good point. Yeah.
Thank you.
So educate people to understand that they shouldn't misbehave. So education is key to everything.
Okay. We can take the next question, please. Okay.
Yeah, so I had a question for Professor Jean-Marie then, and it was about supramolecular polymers. Do you think that we could construct some kind of scaffold or implant to sort of regenerate tissue, for instance?
Yeah, this company has developed, the Exeltis in the Netherlands, has developed these compounds which were supramolecular type by using hydrogen bonding. And I don't know exactly how they did it, but they made these compounds biocompatible. And then they went through all the processes in regulatory also to be able to use it in humans. Now, I think these materials can also be adaptive, since if you submit them to, like for instance, the change in optical properties. This is a material which acquires a property that doesn't have before. In that case, it was seen, and that is, as one says, seeing is believing. So when you see it happening, you think that it works. And the possibility of exchanging groups under the pressure of some external driving force is something which should work in most cases. And we know that the 20 amino acids, they make all the proteins. So you can exchange things, and we heard just a moment ago that by modifying, by driving the evolution, you can then exchange pieces, not necessarily in a sort of a dynamic way, but in some ways it's dynamic also, but you use a reagent to do so. There's another thing which was not mentioned. Many, many years ago, Manfred Eigen, who one doesn't hear much about anymore, but he was a fantastic chemist, he had constructed an evolutionary machine, even a company called Evotech. Now, Evotech is not doing the same thing anymore. It's doing something totally different. And by, for instance, by irradiation of I don't remember what they used, but changing the genetic information by irradiation, killing the beasts, the only ones which survived were the ones which then were able to do the job. That was a sort of I think you must know about this Evotech machine, of course.
Yeah.
It didn't work very well.
No, it didn't work. No. That's why it was abandoned, and Evotech changed completely.
Okay.
But yeah, it was an interesting
No,
idea. Yeah.
But I mean, geneticists do this, right? And
Yeah.
humans have been doing it. So
Dr. King?
Yes, so the subject of AI has come up a number of times, and I'm curious, as Nobel Prize winners, do you think it is possible in the future for an AI system to win a Nobel Prize? And if so, when?
For what? For?
for an AI, an artificial
yeah.
intelligence to win.
Professor
about
Nordén.
Well, first of all, I think most AIs are like 2-year-old children. They really don't know what they're doing. They're trying to adapt. I had a seminar yesterday about AI. We are using AI all the time. And it's terrible for chemistry and structural stuff. And chemistry is structural. It's 3-dimensional. So AI for chemistry is very poor. Whereas for handling words or sequences, it's actually quite strong. But AI only takes up the information that it's already been given. And it can recombine these kind of information pieces, but it cannot create anything new. And this was very clear yesterday when I tested out different types of synthesis. A synthesis that is well known, it gave me exactly what I wanted. A synthesis which was 2 components that had not been combined before. it was a little bit problematic. And then something realistic that I would like to do in the lab, and the answer was totally wrong. So this is actually a good example of how artificial intelligence level is today. It's not very good. It's very good at writing letters or reports. Cannot create anything graphical, really. It's difficult for it. And it doesn't handle three-dimensional structures almost at all. You have, of course, AlphaFold, but that's simply handling existing structures and putting them into new combinations.
So you're right today,
Yeah,
but
exactly.
tomorrow you will be wrong.
Exactly.
Let's see.
I agree with Francis entirely. I think for the moment, what we consider as not possible, maybe by evolution of AI, one can have it, I would say, a driven evolution of AI, we will solve many problems. And in 1,000 years, will not be the same.
So
I'm quite sure.
But the answer to your question
That Nobel Prize.
depends, what
Yeah,
would you
that's
call
another question.
AI? It could be an achievement that is inspired by AI. I would think that's likely. But to have a prize that in itself conceptually is based on AI, I think that's...
Wait a minute, Bengt. It's a robot which will give the prize.
Yeah, I'm a robot.
No, but this is a deep question, right? Because AI can generate hypotheses.
Yep.
It can direct physical experimentation. You can have an agent that goes through everything that I talked about can be automated. We are looking forward to the day you just push the button and you optimize. And if you can push the button and also generate hypotheses, then we'll be able to make all those enzymes that I'm dreaming about.
But Francis, there is a caveat. AI rarely makes you understand.
Right now.
Well, no, but so how much do we need to understand? We want to understand, right? Yeah. We will try very hard to understand, but there are many things that we do without the deep understanding that AI will probably not give us. That said, there's a lot of work on extracting the understanding from AI systems as well.
It's just a calculator.
Okay, thank you.
Let me just comment on that. When I started my PhD, we had the first NMR spectrometer in France at that time. I knew how to repair it. Mm-hmm. Oh. Now, the new ones, no idea, but I know if I push that button, it works.
Right.
The same holds for my car.
Exactly.
Okay. And next question, please.
Dr. Garay is deaf, so she has deaf speech. What types of discussions should we be having? Go ahead.
I'm sorry. I'm deaf, and I've been born deaf, but I'm gifted in speech. So I hope you can hear me.
Very well.
Yeah, sure.
Very well.
And we don't have an interpreter, so I'm going to try to do my best with a question that I've been thinking about all day. And myself, I'm lean more on the humanity side. And as a psychologist and a developmental psychologist for very young children, one of the things that I've learned here today is about the topic of science really shapes the future of humanity. But without humans, we can have no science. And my concern about humanity in the future is that there's so many of us who are not perfect and who are born in this world different and diverse and so on. And as humans, we really have two important things: the desire to reproduce and the desire to control. Whether that be biology, chemistry, genetics, you name it. My concern is that what kinds of discussion should we be having with the next generation of students who will become scientists to ensure the issues about environmental climate, social equity, technology advancements, ethical considerations, because the future of human right now is scary. We're not doing a good job as it relates to how we connect with each other.
Okay.
And without that, I see no science in the future.
Francis,
Well,
would
I'm
you like
asking
to
you what your thoughts are on that?
start?
Thank you.
Thank you.
I can just say I completely agree with you, and that science is there because there are people, and that people will be there because there is science in the future. And we need to discuss that, and we need to appreciate that.
Jean-Marie?
I think the one most important point to teach and to convince young people of is to be free thinking. No barriers. And what you say is right now. In 50 years, it may not be correct anymore, and we will change. And the plasticity, especially, we didn't talk much about the human brain, but the human brain is the most fantastic machine which exists right now, and that is the next frontier. I think freedom of thought is the most important, and critical thought, of course, also.
But I think there is a political dimension in your question too. And it's very important, just as Francis says, to have a discussion. But you can't make laws that you should not do this or that. But so it has to be a very human discussion. I can't envisage where we will land, but I can envisage very complex situations which we cannot predict or foresee, which will make it very necessary to address such issues. So I think it's a very, very important comment and question.
But it's also societal collaboration between decision makers and scientists, because we as scientists are not going to solve the problems of the world. It's going to be a collaboration between political and financial decision makers and scientists who makes the initial very, very important discoveries that leads to solutions of these more global problems, more diversity-oriented problems, political problems. I mean, we have so many crises around the world, it's almost worse than ever, with all the wars that are probably half of them have some sort of element of the climate crisis in them. And so we have now complex, difficult situations to handle. And a single scientist is not going to come up with any kind of solutions to those things. It's going to be a collaborative effort between decision makers and scientists.
Francis, when you speak in your capacity with your thoughts and recommendations, do you see that it goes further than that, or what happens?
So one thing I learned when I got pulled out of my wonderful ivory tower and thrown into the maw of Washington is that science is so easy compared to people. Getting
true.
people to agree on even what's obvious, right? It's obvious that investing in the next generation will give returns, right? That's so obvious. But getting people to agree to actually do it comes into, will I get elected next year if I invest for 20 years? And should that investment go to this, or that? And there's just so many complicated things that go into it.
If we look at this program, all of you have come to invest in the next generations, and you've done it on your time, at expense and everything else. So there are different ways of achieving that, but I guess not on a higher, greater scale?
Yes, I think if you do education and really start to do science as it should be, part of our primary curriculum from first grade, not only math and reading and writing, you're going to see dramatic differences in the development of this world.
Yep.
But it still doesn't solve the political problem, right? Even if our politicians have signed, the priorities are really different. People have different priorities. And getting people to agree on priorities is quite remarkable that we were able to close the ozone hole. I don't think we'd be able to do that now. And these are sorts of things that really should bother us. How do we talk to people and get shared priorities?
Okay, let's go to our next question, please. Thank you.
Yes, okay. Hello. For as long as I can remember, I've been interested in science, and life as a scientist has always been clear to me, life as a postdoctorate. But in later years, as I got older, I heard about the toxicity in the field of science, of how the life of a postdoc can just be like chasing research grants, and you're not really getting to research what you really want to research and what you truly believe in. And so now I have this path set before me, like, should I go into this life or not? So my question is, do you wholeheartedly recommend life as a scientist?
I wish I were a postdoc again. That seems to me the ideal life.
It's the best period of your life, actually, and you have the full freedom of thought. If you think about it, you might get money because you have said that you want to do this, but you can actually do that.
You do have to compete, though. Science is a competitive endeavor.
Yeah, no, I get that. But the thing is, I've always wanted to do things that interest me, and it would be kind of sad being forced into something just so you would get a research grant, for instance.
I'll bet you one thing we all share is we would do it for free.
Yeah.
Right?
Well, that's
Every day is fun. You might have to do another job on the side, but
Thank you. The next question, please.
Inserting synthetic enzymes or molecules could help, for example, Alzheimer's. But how do we ensure that the enzyme doesn't mutate in a way that it hurts the individual?
Well, in that case, if you're referring to what I said, there's no self-regeneration of these molecules that we're talking about. So if it's part of a biological system, of course, they can reproduce itself. But these kind of molecules that we are talking about don't reproduce, so they won't mutate.
But is the possibility that the human body will accidentally
Well, it can be harmful, but you never know until you try. I mean, the vaccines is a typical example. There's a lot of different opinions on that. I hear Francis Arnold have one opinion. I might have another opinion on using a single protein RNA to get a vaccine response. I'm not sure it's the best way. I'm not sure it's we know the consequences of doing it yet. So there's a lot of different opinions about the use of a particular method or drug. And we have to test those things out if we want to have the benefit of the evolution of treatment of diseases.
You cannot start by wanting to exclude all risks. That does not exist. You have to try. And I think the vaccines are a fantastic progress, even if there are side effects. Everything has side effects. Okay, one has to live with it. Perfection does not exist.
Yep.
Okay.
So the vaccines, without the vaccines, we would not be here, sitting here talking with you.
Thanks.
Okay.
And one point I want to make about these vaccines also is characteristic of science. How did they occur? There were two people, Katalin Karikó, she was very tenacious and hanging on, and Drew Weissman together. She was Hungarian. She is still Hungarian. I am not sure, maybe she's an American now. Then Drew Weissman is American, and it was produced by a company in Germany, not Pfizer, BioNTech, which is directed by two people of Turkish ascent. There were two people coming whose parents were Turkish, one Hungarian and one American. Nobody could have predicted that. So you just wait, it will be solved eventually. And science functions that way. You don't know where the shot comes from.
Solutions come from diversity.
Diversity. I mean, no barriers. Diversity, you call it. I call it no barriers.
Yeah, I got another question. Yes. When we test a vaccine, how long should we wait until we are sure that the vaccine won't be negative in the future, or that it won't have a negative effect?
If you wait too long, you will be dead before that.
And you will never be sure.
You will never be sure, anyway. There's always a percentage of risk.
Yeah.
There's a question in the middle. I know you don't have the microphone. I'm not sure where that is, but do you want to try? Yeah, try.
I don't hear anything.
You have to be shout a little louder.
Okay, I'll try not to sound too angry. This is specifically to Morten. Very, very impressive, all of the things that you presented there. Specifically about the amyloid plaque Alzheimer's thing, there have been some recent distractions and debate. Of course, no way affects the basic work that you're doing. But I was just wondering, do you have any thoughts about this? The link between amyloid plaques and Alzheimer's?
Yeah, I do. Actually, I think that's my personal thought, but I think that some of the toxicity that you see could be due to this proteolytic activity of these enzymes, because these aggregates, because you find NCAM fragments around the plaques, and NCAM is the molecule that keeps the neurons together in close contact and allows them to thrive. So if you cleave NCAM and dilute this number of NCAM molecules on the surface, they tend to die. And this could be part of the toxicity that you see in the plaques. So I think that every time you do a new discovery, you have the possibilities to intervene in this kind of way by this new discovery.
Thank you. So I'm going to ask you, since we're almost finished with today, if each of you could just take a couple minutes and either summarize what you thought was the most important thing you learned today, or something that you really wish to impart on the audience before you leave. Francis, you want to start?
No. What did I learn today?
I can say a few words. I mean, I'm a chemist, and my message, if you haven't got it before, is that chemistry and science in general is useful. So you should look at your curriculum at school and apply it on the various problems that challenge you. We heard today from Jean-Marie about how to combine different components, and the combinations were interesting, and he said that the system always have the tendency of, so to say, crystallizing, to ordering itself. Now, this is something that comes out of physical chemistry, something called thermodynamics. There are two parts in the thermodynamics. There is the part that is called enthalpy, which is sort of energy. And the enthalpy determines whether there will be strong interactions. It could be repulsion or it could be attraction. And then there is another part that has to do with disorder, mixing, and that's called entropy. And the formula for this is extremely simple. And you could apply this, and then you could immediately see that, that you are right, Jean-Marie, and you could tell exactly how right you are. So this is my tip now, to use what you learn at school and apply it to the various problems we have discussed today. Yeah.
Okay, thank you. Professor Meda?
In science, we always think that we know everything, but I think we just scratch the surface of the knowledge, and there's so much for you young people to go out and discover. One of the things that I think is very important is that we have not yet understood molecular recognition, and the reason I say that is because we cannot calculate it.
No.
So if you have an antibody, for example, that recognizes a particular surface with a number of hydrogen bonds, hydrophobic surfaces, and so on, so you know exactly how these are going to behave according to our calculations, and you have another one that does the same thing, but the difference in binding constant can be 100 million. So that means that we really don't understand exactly how these two molecules interact, what is happening between the bonding, anti-bonding orbitals, and so on.
Thank you. Jean-Marie Lin?
I don't think we know everything. That you started that way. On the other, I'm convinced that a lot of things we don't know, and that this opens in an illimited number of possibilities, and one should just repeat, think freely, things will come up. Today I learned a lot about driven evolution. I knew, of course, some of your work, but not in the way you have presented it. This is fantastic. You know, there was a book nobody knows about here, for sure, which was called Scientific Creation, La Création Scientifique. That was written by an engineer who was a sociologist. He had transferred to sociology and to psychology, engineering ways of solving things. And he had a method to have a table with two entries, vertical and horizontal. And vertical were, for instance, different kind of properties, and then horizontal were different types of applications. And if you now add the application driven evolution, you can again then compose all the others which have to do with driven evolution. And so I think there's a whole range of things opening up. So there is a way of even, I would say, a sort of almost automatic, once you see this different thing, an automatic way to apply it, to apply this new consideration, new approach. Driven evolution was something which was known and people have thought about, but not in an efficient way, not the way it can now be done and the way you did it. And I think this is the way science progresses. And on this, other people will build, and that is your job.
Thank you.
Yeah. I like getting the last word.
Yeah, good.
But I think today was a great example, Lorie, of the tremendous breadth of chemistry. Right? We heard everything from origin of life to little nano cars and evolution and polymers and complex systems and click chemistry. What a field where there's so much creativity. And that's human invention, right? All of us are building things. That's why I love chemistry, because it's like engineering. You can build these remarkable things so that you can also study the natural world, which is a fabulous source of inspiration, but you can go beyond it and build things that don't yet exist and discover whole new worlds. So I think that's why I get so excited about chemistry.
Yeah, I know.
I would like to comment on that.
Please do.
I started by mentioning physics. Physics are the basic laws. You cannot get away with those. That is it. That's the way it is. And it's finished. Our universe is made on basic laws, and that's it. They are the constraints. You cannot do anything else. But just to illustrate this, what chemistry can do. I think it was 2011, it was the year of chemistry. UNESCO had said. And so the French physicist asked me, what is happening in chemistry now? Tell us something. Okay, I would tell you everything I wrote then, but the conclusion was commenting on the fact that there are laws and expression of these laws like human beings. That the laws of acoustics, that is physics, you cannot get you cannot do out without them. You have to follow these laws to make sounds. But the laws of physics don't contain all the music you can write with it. The laws of acoustics cannot define all the type of music you can do. The laws of acoustics don't contain all the Beethoven symphonies.
Excellent.
Or that I conclude that chemistry is to physics the symphonies written with the laws of acoustics.
Yeah, very good. So chemistry is much more complex. It's like music.
Okay.
We begin to agree, Bengt.
Yeah.
All right. Well, if you're...
Maybe I could finish. Nobody.
Everybody wants the last word.
Nobody here should really be afraid of silicon as an alternative life form, because silicon cannot form double bonds, in particular, not with itself.
Yes, yes.
And this is one of the major requirements
said
for
it.
developing life.
What about sulfur?
Yeah, sulfur is hypervalent. It can do double bonds where we would have a tendency to write a single bond.
Yeah.
Well, this seems like a discussion that maybe some of you are going to want to continue during the reception that will occur right after this for students. And I want to thank you all very much for this exciting day. And tomorrow, day 2 of the program promises to be just as motivating, so please arrive by 8:45 because we'll start again promptly. I want to thank again our hosts and sponsors, and the many volunteers who made this such an exciting and interesting day. So I look forward to seeing you all tomorrow, and thank you all for everything.
And thank you, Lorie.